See, there we go. Okay, so what we're going to work on today is percents. And I know that on every TEAS exam, there are multiple percent problems. So we actually are going to spend pretty much the whole day just on percents, because that's normally where the students mess up. Now, what happens is that percents are hard, right? There are a lot of ways I can ask a problem, and depending on how I ask the problem, you have to set it up differently. Now, what happens is a lot of 7th grade and 8th grade teachers cheat, where rather than teach you every type of percent problem, what they do is they teach you a song or an acronym or a rhyme, and that works only on the easy problems. And when we get to the harder problems, that doesn't work. So I've been teaching this class for a long time. So I always start out with saying, use my technique, because my technique will work for every problem. It's not like if it's this problem, use technique 1, if it's that problem, use technique 2. The way I'm going to teach you how to do it, it will always work. So you have only one technique that you bring to every problem. So when I first start teaching this, I'll start doing it and people go, I get it, I get it, I get it. And all of a sudden, oh, wait a second, I'm not getting these problems correct anymore. And that's because I started doing the ones where the acronym and the little rhymes don't work. So on the TEAS test, they're going to give you the problems where the rhymes and the little acronyms don't work. So those little tricks your teachers taught you where they go, you don't have to understand it, just turn your brain off and always do it this way. You don't have to know what the numbers mean. Just like do it this way. Bigger one goes on the denominator or bigger one goes on the top. However they taught you, it all falls apart. Because the TEAS knows that there are certain students who understand percents, and there are certain students that only understand the easy ones. And what they want to do is separate you guys, right? There's too many people who want to become a nurse, and there's just not enough slots. So what they want to do is say, well, let's just get rid of all the people who cannot do percents at a more difficult level. Okay. So my recommendation is this: do not go back to your previous understanding of percents. Just start with how I teach you, and if you do that from the beginning, everything will make sense. And if you don't, halfway through it, you'll go, oh crap, wait, can you say that all over again? And I'll tell you, watch the beginning of the video. Okay, now let me pop up my other computer. Give me 1 second. Okay, sorry about that. Okay, now let's look at what numbers come up in a percent problem. Okay, so let's say that I have a dress that's $80 and that my tax is, oh, sorry, my sale is 10%. So my sale price is $70. Okay. So the first thing I want you to see is that I want you to be able to know what is the original price of an item. So that's the first thing we have to identify. So if something is on sale, or if you're going to pay tax on something, what is the original thing that we're looking at? The original thing we are looking at without a sale is the dress. Okay. Oops. I should say the original item. Okay. Now, from this original item, we can subtract or we can add, right? So sometimes if you had a different problem, where let's say I had a shirt that was $50, and then my tax, let's say, is 10%, and then the register price would be $55. Now notice that I'm not teaching you how to compute these yet. I'm just telling you that there is something that is what we start with, right? Whether it's a dress or a shirt, and either we're going to add something to it or we're going to subtract something to it. Okay. Now, the thing that makes percents a lot easier is if we look at, let's say, the dress. Now, if I look at this as a ratio, oh, I'm sorry. Now, whenever we look at the original item, that is 100% of the item. Okay, so the full cost of the dress, right? 100% cost of the dress is $80. So let's write that. So the original item or full cost is always 100%. Now, understand that this is a fraction. So you can simplify this like a fraction. I can say that $40 is 50%. I can say $8 is 10%. All I'm doing is simplifying that fraction. I can say $4 is 5%, right? Each one of these fractions are exactly equal to each other. So if I wanted to look at a percent of an item, I can just simplify this so I get the percent on the bottom. The other thing that you can do with percents is that if I want 15%, I can say $8 plus $4 is equal to 10% plus 5% is equal to $12 is 15%. That actually works.
Professor, I have a question, Professor.
Sure.
You say, how do we know the $8 is 10%, $4 is 5%?
Oh, simplify. Right? 80 over 10. If I remove a 0 from both of these, I get 8 over 10. If I divide this by 2 and divide this by 2, 40 over 50.
Oh, okay, got it. Thank you.
So yeah, so I want you to see that each one of these are exactly the same, right? So one way of looking at this problem, right? So we're saying the sale price, I'm sorry, not sale price. We're saying that the dress over 100% should be equal to 10% over the tax, right? Because we said the tax is 10% and that's 100%. Now, is that true? Oh, I'm sorry. We should say sale. Not the sale price, but the sale markup. Meaning that how much cheaper is your dress? Okay. So that should be $80 over 100% should be equal to, oh, I'm sorry, the sale price is 72, my bad.
Yeah, I was gonna say.
Yeah, I'm sorry, my bad. Okay. Sorry about that. Okay. So we have the markup is $8 over 10%. And we could see that this is equal to this. Okay. Now, in the same way, let me let people have a chance to copy. I'm sorry about that mistake.
Professor, also the sale dollar 10%. I think you should take off the dollar mark because it.
Oh, yeah, yeah. Okay. Yeah. Okay. Now, in the same way, we can say the address 100% is equal to the sale price, which is 100% minus the 10% that it's on sale. So you would get $80 over 100% is equal to 72 over 90%. So if I was to use a calculator to figure out this and use a calculator to figure out this would give me 0.8 and this would give me 0.8. It gives me the same fraction. So I want you to see that when we convert, when we have address and says this is a sale, what's the sale price? We can make these relationships, right? These ratios, and then solve for these things. Okay, so let's start with this problem over here. Let me take a picture now that I made corrections of a lot of mistakes I made. Okay. So let's do the shirt tax register price. Okay. So let's start with this one over here. Okay. So right now we're going to ignore how to compute a percentage. So we're going to say a shirt costs 50. We're going to say tax is 10%. We're going to say the register price is 55. Okay. We'll make this look like 55. And we're going to say that this is 100% of the cost of the shirt. And we're going to say that this is 100% plus tax. All right. Now, the kind of problem you see on the TEAS will be given something like this, where they'll say, you pay $55 at the register if tax was 10%. What was the cost of the item?
Okay, Professor, let me ask a question first. Let me first ask a question. Register price is a sales price.
Well, on this one, there's no sales price.
No, what about
cost-
what does it mean register price?
Oh, when you when you go and you go to the store and you buy something for $50, it's not really $50. You go to the register and then they add tax.
Oh, that means the register price is already under tax.
Yes, the shirt plus the 10% tax.
Okay, got. Thank you.
Okay. So what they usually do is normally the little acronyms of the songs they give you is they give you this and they give you this and they say find this. What they like to do in the TEAS is give you this and find you, and they want you to find that. Okay. So if you are using the acronyms, there's a lot of algebra that happens if you're using the acronyms. But if you're using the technique I'm going to show you right now, the same thing, you do the same technique regardless of what kind of problem it is. Whether they give you this and they want this, or they give you this and this and they want that. Okay. So what you want to do is you want to say, what is the original item? The original item is the shirt. And the shirt, the original item is always 100%. And then the register price is, they gave you as 55 in this problem. And then they go 110%.
But I have the question, Professor. Is
Sure.
use this 100% over that one? That one you put X. Use original price always 100%. But
Yes.
the original price this is $50.
Yes. Yes. So we're going to get $50, but I want to, right now I'm showing you with the answer here so you could see it, right?
Okay.
Normally
okay.
people see it this way where they go $50, $5 tax, $55 at the cash register. Okay. That's how
Okay.
most people see this problem. So that's why I put it here. But I want to show you that what the TEAS likes to do most often is give you the final answer and want you to go backwards.
Okay. Now can I put the 50 over 100% here?
Well, right now 50 is not in the question. So
Okay.
I'm just showing you what the three numbers are. This, this,
Okay.
and this. These are the three numbers they give you. And they'll give you
Okay.
2 of the 3.
Okay. Thank you.
So in this question, they didn't say $50. We have to find the $50. So the way we do it, we go x divided by 1.00 is equal to 55 divided by 1.10. So this is equal to 1, and this is equal to 5. I'm sorry, 50. Okay. Now let me give you one where I don't give you give you the numbers. So Jim got a 5% raise. He makes $20 an hour now. What did he used to make? Okay. So what he used to make is his original salary. Okay. So full price was his, the original price was his prior salary. So this is the original salary. Okay. But what he makes now is 20%. And he makes 100% plus his 5% raise. Oh, I'm sorry, $20. So you have X over 1 is equal to 20 divided by 1.05. So he had, if we round it, 19.05 like that. So let's try this again. Okay. The sale price of a dress is $60 if the sale is 20%. What was the original cost of the dress? Okay. Let's try it. So the sale price is $60, and that's 100% minus the 20%. And the dress, the original dress price is 100%, right? So it wants the original cost. So full cost or original cost, that is always the 100%. So we have X over 1.00. Oh, sorry, 0.8. Okay.
75.
X is equal to 75. Okay. Now we're going to go back and forth between maybe I give you this one, maybe I give you this one. So you're able to do both of them depending on how the question is worded. Okay. So we'll say Mike used to weigh 150 pounds. So that's pounds. He lost 15% of, well, let's make it a different one. Let's say 12% of his body weight. What is his new weight?
Professor, I got 132.
Let's see, let me try it. So let's remember that the key question is when you look at the 150, is that the original weight or is that the new weight? Because it's the original weight, right, is 100%. So this is the original weight. So you have 150 over 100% is equal to X over 12%. I'm sorry. 100%
Minus 12%.
minus 12%. Yeah. So now we get 150 divided by 1.00 is equal to X over 0.88. And I can use cross multiplication and I can bring the 88 over here. So I have X is equal to 150 times 0.88. And then X will be equal to
132.
Oh, 132. Nice job. Good job.
Yeah.
Yay. All right. So let's try another one. So let's do Mike. Lost 20% of his cash if he has $80. How much? Let's make this $70. Did he start with?
I got
Mhm.
$56.
Okay, but give everyone a
I-
second.
I don't know
Give
correct
everyone a
or not
second to figure it out.
correct.
I don't know. Give everyone a second. I'll do it in a second. Right? I'll give everyone a second to do it on their own. So don't yell out the answers, right? Give everyone a chance to do it on their own first. So we have $70 is how much he has after he lost his money. So we want to know how much did he have when he was at 100%. Okay, so then this is x over 1.00 is equal to 70 over 0.80. So that looks like $56, doesn't it?
No, I'm
You make
wrong,
sure?
Professor. I'm wrong.
You're wrong? Okay.
Yeah.
No, that's not right. Maybe you're right. I'm doing it by my head. Oh, wait. 70 divided by 0.80. Oh, I'm sorry. 87.5. It can't be 56 because that would be less money. Did you say 87.5?
Oh no, I said $56. But my
Oh,
question
okay.
is, he lost 25%. He lost 25%. That means 100% minus 20%.
Well, remember that he has this much now. So the original, like how much money did he have originally was more. Right? So he has $70 now, but this is after he lost his 20%. Right? He has 87.50. And then he lost some money. And now he has $70. Right? So that's my original minus 20%.
Okay, I got it. Thank you.
You got it? Okay.
Got it. Thank you, Professor.
Uh-huh. Okay, so let's try it again. Okay. Kim has put $100 in the bank. She gained 15%. How much does she have now?
Now he has
Oh,
$115.
wait. Don't yell out the answers, okay? Give everyone a chance to do it. So don't yell out the answers, okay? All right. So we're saying that she started out with $100, and that's the 100%. And then this is equal to x over 100% plus 15%, right? That's how much extra she has. So now she has $100 over 1.00 is equal to x over 1.15 X is equal to 1.15 times 100. And then you're right, it's 115. Okay. All right, so don't yell at the answers. Give everyone a chance to try it. Okay. I'm glad you're understanding it, but give everyone a chance to try it first. Okay, now. So what we did is we worked on problems that look like this. Where I said, I'm giving you the 100% value and you give me the altered value. Or I'm giving you the altered value and you give me the original value. Okay. So let's look at the next question. Okay. So the next question is, how do I actually find a percent? So if you give me this and this number, how do I find a percent? Okay. Now there's basically three kinds of problems here. Now let's get rid of the more straightforward one. So if I say 3 out of 5 balls are red. Okay. When we try to find the percent, so when we go find the percent, we're talking about the number of red balls over the total balls. Okay. So we have 3 out of 5 is equal to 0.60. It's equal to 60%. So that's the most straightforward kind of percent problem that there is, like find the percent, is when you go, I have this many out of this many, what percent is it, right? It's the small amount over the total, and that gives me my percentage. Let me let everyone copy that, and then we'll do a few variations on this. Okay. So for these questions, okay, there are only red and green balls. Okay. For these examples right here. So if I say 3 out of 20 balls are red, what percent are green?
%85% are green.
Okay. All right. What do I keep telling you, Juan?
Okay, got it. Thank you.
Okay, don't yell at the answer, okay? So the information they gave us are red, right? So, but what we need to know is green over total balls. So if there are 20 balls and 3 of them are red, that means 20 minus 3, which is 17, are green. And I think that's what, let's see, 85%. Let's see, 17 divided by 20. Yeah. Okay. So the straightforward way they can give it to you is this way. I would think that they're probably going to switch it up, give you something like this, something that's binary, and give you the other thing. Okay. Now, the other way they can give you this problem is they can give it to you this way, or they go, there are 5 red balls and 3 green balls. What percent are red? Okay, don't yell your answer, give everyone a chance. Okay. So this is so we're saying what percent are red? We want red over total balls. And these are 5 over
8.
5 plus 3. Yeah, thank you. So let's see what that is. So I get 0.625 is equal to 62.5%. Okay. So that's the straightforward one where they say, I have some subset of things. What percent is that subset? And they can give you that, they can tell you what it is. They can make it binary where they give you the opposite number, or they can give you how many are in the 2 subsets, and then you can add it up. Okay. So let's do one more like this. Okay. So now let's get away from our red ball, green ball requirement and say, there are 2 dogs, 6 cats, and 4 lizards. What percent are lizards? Okay, so let's look at this. So we have lizards over total. So I have 4 lizards over 2 plus 6 plus 4. 4 divided by 12. So that should be 30 something percent. Let's see what percent it is exactly. Okay. Oh. It's equal to 0.33 bar. We'll say it's roughly 33%. Well, we'll write it like this. So I can't put the bar like that. Okay. So that's one type of find the percent. See, let me give everyone a chance to copy that. And then we'll go to the next type, right? Okay, now let's erase this. Now, the next problem is sometimes telegraphed by saying find the percent increase or the percent decrease or the percent change. Or sometimes it just says find percent, and they don't sort of warn you that this is the second type of percent problem. Okay. Now, when I used to manage the math lab, so I used to manage the math lab, and we found out by the data that students who went to the math lab, 50% of them passed their class, 50% of them flunked. Okay. Okay. But we figured out that if you did get tutoring, then you were at 60%. So we figured out that with tutoring, that 60% passed. So my boss is an English major. So he wrote a report and goes, look how good we did. We have a 10% change in our success rate for students passing. I go, that's not 10%. That's 20%. He goes, what do you mean it's 20%? I said, because it's not 60% minus 50%. That's the net change. What we're looking at is compared to the 50%, compared to where we started, how well are we doing now? So there's 2 ways to ask this problem. Okay. One way to ask this problem is to give you this number and this number. Okay, these 2. So you say 10% more students pass with tutoring, 50% pass in total without tutoring. So what they did is they gave you these 2 numbers. They didn't give you this number. But you could calculate it. You could just add the 10% to the 50%. But they said there was a 10% change, and we started from 50%. Okay. So if you ask me, what is the percent increase? So compared to the 50%, how big is that 10%? Then you just do 10, right? So this is the amount changed. Over the 50. This is the original amount. So I get 0.20, so I get a 20% increase. Okay. And then after that, my boss said, you know what? Could you redo all my reports to do that? Because he didn't quite understand what I did, but he trusted that I did it right. And he's like, wow, if you could make all my numbers go up magically and defend it mathematically, make all my numbers get better. But this is a more accurate description. Compared to 50%, this 10% is really big. Okay, so let's give you the other way they can ask this question. Okay. So let me give everyone a chance to copy that. Okay, so let's look at this. Now, what's going on here is that we're giving you the starting point, and then we're giving the ending value. So we are giving you these two values, And what is missing is this. But what we can see is that when we're trying to compute the percent increase or the percent change or the percent decrease, the two values we need are the original value and the difference. Okay. So the way you could calculate this, right? Because what we want is the original value. Okay. What did we start at? That's what we want on the bottom. And then on the top, we want the difference. Now, these percents are always a positive number. So whether you say percent increase or percent decrease, right? Whether this new number went down or up, it's always a positive number. So you're always doing the big number minus the small number. Divided by the original value. Okay. So it is 60 minus 50 divided by the original value is 50. So then we get our 10 divided by 50 is equal to 0.20 is equal to 20%. Just like we did over here, it's just that in this problem, they gave us these two, right? Where I started from, what the difference is. And over here, they gave me where I started from and where I ended at, and you have to compute the difference. See you, honey. Have a nice day. Okay. Okay. So let's try something. Okay. Jim lost 20 pounds from when he was okay. Jim lost 20 pounds. He used to weigh 200 pounds. What is his percent decrease? Okay. So I want you to do that problem, and I want you to compare it with this problem. Okay, so try both of those. Okay, so let's look at the one on the right. Okay. So on the one on the right, he used to weigh 200 pounds, and then he lost 20, so now he's 180. So we're looking at 20 divided by 200, so it should be 0.10 is equal to 10%. Okay. Now let's look at this one. He weighs 200 pounds now, and he lost 20 pounds, which means that he now weighs 200 minus 20 pounds, which is equal to 180 pounds. So this one is 20 divided by 180. Okay. And this is 0.11%. Okay. All right, we've been pushing pretty hard. Let's take a 5-minute break and then let's come back to this and we'll knock out a few more percent problems. But we've pretty much done percents. So what we're going to do now is consecutive number problems, and then we'll go back and forth between different percent problems. Okay? Okay, thank you. All right, let's take a 5-minute break. Everyone's head will be more clear after we finish this break. Okay, so let's get back to this. So before we go and go back to percents, let's work a little bit on consecutive numbers. Now, this isn't on every test, but talking to former students, they've told me that they've seen this on the test. So there's a quick way of doing problems that say consecutive numbers. Okay, so let me show you what I mean. Okay. The sum of two consecutive numbers is 87. Okay. And then the question is, what are the two numbers? Now, when we're talking about consecutive numbers, we're talking about numbers that are right next to each other, where I take two numbers, I add them together, and that's the sum that I get. Okay? Sometimes they'll ask you to add three numbers. And you'll get, in this case, 10. Okay, so this is two consecutive numbers, that's three consecutive numbers. Now, the normal way they teach you how to solve this problem is to go x plus
Professor,
x plus
Professor,
1.
why is that one got a 10?
Isn't it 9?
9?
Oh, is it 9? Okay, 9, no problem. Okay. Now, the normal way they ask you to solve this problem is that they say this is the first number and the second number is this number plus 1. Just like this is 5 and the 6 is 5 plus 1. Okay. And the normal way they ask you to solve this is to do this and go 2x plus 1 is equal to 87. 2x is equal to 86. X is equal to 43. And then x plus 1 is 43 plus 1 is equal to 44. Okay, that's the typical way they ask you to solve that problem.
Wait, Professor, what do you mean x plus 1 equals 43 plus 1? Isn't that minus 1?
If you do minus 1, then it'll still work, but you'll get, oh, you're right. No. Because x plus 1, you're just substituting. You're not saying x plus 1 is equal to 43. You're saying the first number is 43, and the next number is 43 plus 1. Does that make better sense? You're not saying this is equal to that. You're just substituting this value into this x over here. So it
Got
may
it.
be easier to understand if I wrote it like this. I substitute this into here, I get 43 plus 1, which turns into 44. Is that a little better? Okay, so the x will always give you the first number, and then the next one is you can just either use common sense, the next number is the next number after 43, or you could do plus 1.
So
Now, go ahead.
so that's the formula for that, right? The
Yeah,
formula.
but I think there's a better way to do it. Okay. So I'm going to show you my cheat method, which is faster, and there's fewer things for you to memorize. because there's a technique for consecutive odd numbers, consecutive even numbers, 3 consecutive numbers. So rather than doing that, what I propose is that you cheat with your calculator. Okay. What you want to do is do 87 divided by 2. This equals 40.5. This gives you the middle value. So I need the number that's smaller than it and the number that's bigger than it. Oh, I'm sorry. This gives you 43. So I need the number that's smaller than 43 and the number bigger than 43. Do you see how that works? Okay. Now I like this cheat method because it works on every consecutive number problem. If you just remember that when I divide it, it gives me the middle number. Now, then I just have to answer the question. What are the consecutive numbers surrounding this number? Okay. So let me try, I'll try a different one. Actually, let me make it not 66, but let's make it not intuitive. 96.
I got one number, Professor. I got
Oh,
one.
okay, wait. Don't yell it out. Don't yell it out. Okay. So you got a number. Okay, and then do the big number and the small number. The number bigger and the number smaller than it. Okay. All right, give everyone a chance to think about it. Okay, so when I divide it, 96 divided by 3, this gives me 32. That's the middle number. Now I want the number that's smaller and the number that's bigger. The number that's small is 31 and the number that's bigger is 33. Because there's 3 numbers, this one actually is one of the numbers. Okay, so when it's even, this is when you're dividing by an even number, you'll get a fraction and you go left side, right side. When it's an odd number and you divide, that middle number will be part of your answer. And you'll know because it won't be a fraction. Okay, so let's try it again. Let's take a picture of this.
That's pretty awesome, Professor. Thank you. I usually do the long way.
Okay, yeah, it's a lot worse, right? Okay, let's try this again. I taught this to my students, and then they took a different teacher, and then they did that, and the teacher goes, "You can't do that," and she's like, "How come? It's faster." He's like, "You still can't do that." I'm like, why? I get the right answer. It's like somehow there's something wrong about that. She's like, why? It's easier, it's faster, it's simpler, and I get the right answer. And he's like, I don't care. Now I'm not like that. I used to
As
get
long as you
paid
get
for
the
my
right
time.
answer, right?
Yeah, I get paid for my time. So my boss says, like, if you can do something faster, do something faster because you cost me less money. Okay, so let's try it again. Fine.
Especially in TEAS exam, we need to save time.
Yes. Of 2. Okay, now we're going to say even numbers. So when you divide by 2, I want you to give me the even numbers around it, okay? The sum of two even numbers. Oh, give me, find the two even numbers that sum to 48. Let me make sure that works. No, that's not right. 46, that worked. Okay, try that one. Now remember, your numbers should be even. So whatever answers you give me the before and after of the even numbers. Oh, I should say find two, no of. Okay. So we're gonna go 46 divided by 2 is equal to 23. Now that's not even. I want the numbers that are before and after that are even. That's even, that's even. Boom and boom. Okay. Now let's try one last one. Now remember, your answers are going to be odd. Oh, and then if you haven't, please be sure to type your name in the chat so I know that you're here.
14, 16.
Shh, don't say anything. Okay. So we're going to go 45 divided by 3 is going to be 15. That's odd. And then the odd numbers before that. And then we're done. Okay. So that should be a question that you get
Oh,
right.
Professor, 14 and 16. Why you put
14,
why you
because they have to
put
be odd numbers. Odd
Oh,
numbers.
okay, okay. Thank you.
Okay. So if it's a consecutive numbers, you're correct. 14 and 16. But remember, they said odd. Okay. So let's take a picture of this. Okay. Now let's work on um, some different type of percent problems. So for your homework, let me show you. Ooh, that is small. Okay. I'm basically gonna send you this file here. Now this is long, it's 9 pages. So, oops, let me make sure you can see it. So this is 9 pages and it goes back and forth between percent problems, different kind of percent problems, and translation problems. So the problems that we did um, last week, so they look like, let me see, I think they're more on down here. Oh, here, the difference of twice the number is 6 times. So I'm saying do up to page 5. Now I would recommend doing the whole thing. Only because these are the type of questions that absolutely show up on your test. Okay. So instead of 5, let me say do up to page 7, because then you'll get because I think the first 4 pages is mostly percents. So I'm gonna put it in your new homework. I'll say do up to the first 7 pages. Okay. Now the other one is this random word problem file that I'm going to send you. And I like this one because it's not written by me, right? Sometimes teachers get into the habit of writing their problems in exactly the same way. And since I'm not writing your TEAS, someone else is, it's good to look at a different author writing percent problems. So let's start working through this. So let's do question 1. Now I'm going to put this also in the chat, but I had mailed it to you earlier. It's called random percent word problems. And this is also on your homework. Okay. So let's pop this up. I put it in the chat. Okay. So try doing question 1. And just so you know, all the answers are on the bottom of the file.
Professor, you didn't send us on the chat. Nothing. There is nothing.
There's nothing there. Let me try it again.
It's right there. It says random percent word problems. It's a file.
Yeah. Do you you know what? I'll send it to everyone's email right now too. So if you don't see it there, I'll send it to your email right now. Okay.
Yeah, Professor's email is
Thank you.
the email.
Okay.
Professor, can you show your question?
Yeah, give me 1 second. Give me 1 second. Let me send it to email to everyone real quick. Let me go here, here, and then here. Okay. And then okay, check your email.
Yes, I received it.
You received it? Hey, Edgar, do you have a different email that you'd like me to send email to you? Because I could send it to both of them. So if you have an email that you trust more.
No, I just received the one you sent.
Uh-huh.
But I sent you a message too. I don't know if you have a chance after class. Or
Yeah,
not.
I saw the email. So if you have a different email that I can send it to you, we can do that. And then the other thing we can do is I'm going to type my phone number in there. So if you want to text me your phone number and say, could you text me the files? I can maybe try doing that also. Okay. Because, you know, like I don't want you to get thrown off because the email server is off. So if you have a different email, you can also call me saying, hey, I didn't get anything. Because I remember getting an email from you early on saying that, hey, where's the homework, right? So I believe you when you say that something weird's going on with the email. So I can work with you, but you have my phone number and we can figure something out. Okay.
Thank you.
All right. So let's look at this one over here. Okay. Go ahead, give it a shot. Don't yell out the answers. Okay. So 15% are strawberry. And we know that you have 30 strawberry. So you want to know, oops, I'm sorry. Let's go the other way. 30 over 15%. And we know that total, we want to know how many is there in terms of 100%. So X is equal to 30 divided by 0.15 is equal to, that looks like
200.
200. How much is it?
200.
200? Yeah, looks like it. Yeah, 200. Okay. All right. So don't yell at the answers in, but that was perfect, Len. You got it. Let's try question 2. No, don't yell at the answer. So we know for sure that 54 students is 27% of the class, right? These are the ones that failed. Okay. What we want to know is how many people passed. Okay. So that'll be 100% minus the number of people who failed. Okay. So we should get X is equal to 54 times 73 divided by 0.27. So I got 146. Try doing question 3. Now, when you redo this for homework, I'm doing some of these so you have some help. Do it cold. Like, don't look at the work. See if you get it. If you didn't get the right answer, look at the work. The answers are on the bottom. Okay, now this one wants us to find out percents. So we went from 15,000% to 12,000. Too many zeros. Okay. So that's a difference of 3,000. So the percent is equal to the original amount, the bigger number, minus a smaller number, divided by the original amount. So that's equal to 0.20 equal to 20%. Let me make that prettier. That. Let's take a picture. Okay. Give everyone a chance to copy that. Okay. Okay, so let's clear this one. So let's go down here. Okay, try doing question 4 and question 5. Oh wait, can't quite see all of it, can we? Let's see. Okay. So when we look at this one, the way to look to help yourself is 20% have blue eyes, 75% don't have blue eyes. Okay. So normally we need 3 numbers, right, in order to solve this because we have a fraction equal to a fraction. There's 4 numbers in. So over here, we're given only 2 numbers. So you've got to suss out that if 75% do not have blue eyes, then 25% do have blue eyes. Okay. So go ahead and make your fraction equal, right? People who have blue eyes equal to people who don't have blue eyes. Okay, so let's take a look at this. We have 140 have blue eyes, and that's 25% of the team. What we don't know is how many do not have blue eyes, and that's 75% of the team. Okay. So X is equal to 140 times 0.75 divided by 0.25 is equal to 420. Okay. All right, try question 5. So in this one, right, we need 3 numbers. I'm only given 2 numbers. Okay, so let's remember total number of students is equal to 100%. Okay, so we have 225 over 15% is equal to the total number of students over 100%. Okay,
I got
So
1,500.
1,500, I think so. I don't know. Let's see. It sounds pretty good. X. Okay, so I mean, I think you're right. 225 divided by 0.15. Yeah, 1,500. Is that what you got?
Yes, 1,500.
Yeah, 1,500. Yeah. Yeah, so you got it perfect. So that's good. Right? These aren't easy questions, so it's good if you're getting these. Okay. All right, so let's clear this. Uh-huh. Go ahead. Do you have a question?
Professor, question number 4.
Uh-huh. Question number 4, yes.
Yes, I did is one. I did wrong, but I did wrong. I did is 140 over 100% because
Well,
the 140 members of football club have the blue eyes. 70% of the members football
okay, so let's look at it,
do
right?
not
So
have.
25% have, so let's look at blue eyes, right? So blue eyes is 140 players, and it's also, but we don't know how many percent, right? So not blue eyes is 75%. Okay, so that means that blue eyes is going to be 25%, right? Because blue eyes plus not blue eyes is equal to 70. Blue eyes plus not blue eyes should be equal to 100%. So that's why what we do is we then get 140 over 25%
Mhm.
is equal to
Okay,
X. Is that better?
got it. Thank you.
Okay,
Thank you so much, Professor. Got it.
no problem. Like that. Oop. Like that. Oop, that. Okay, like that. All right, so let's clear this one. All right. So let's go down over here.
Professor, after you're done doing this, can I ask you a question from previous homework? I couldn't.
Yeah,
do-
you can ask me right now. Let's do that first. Okay, we'll come back to this. What was your previous homework question?
So it's from converting English metric to you know.
Mhm.
So 18.5 cubic
Okay.
feet
Yeah. So what are you trying to convert?
and cubic meter. 18.
Oh, cubic meter? You know what?
Yeah.
Don't worry about cubic meter.
Oh, okay. So we
I should have
don't.
told you to ignore those. Yeah, ignore cubic meter.
Sorry. Okay. Thank you.
Okay. No, it's my fault. I didn't wave you off those questions. Did anyone else have questions from previous homeworks? But we can always just start with that. So you never have to worry. Okay. Okay. So let's do.
Professor, I had a question regarding the homework.
Sure.
I'm trying to go back to the homework real quick. 1 second. It was a ratio and rate word problems.
Mhm.
Number 8. For some reason, I kept getting confused. I mean, I got it afterwards, but is there like a shorter shortcut for that one?
Yeah, let's look at it. So this one was, so let me pop up the homework. This is from last week, right?
Right.
All right. So we're looking at the, do you remember which file? Is it the gay 6.3a ratio problems? Or is
Yes.
it the ratio word problem? All right. So this one, all right. And then do you remember which question?
Number 8.
Number 8, okay.
The ratio
Oh,
of marbles and blue marbles.
blue marbles. Let me see. Number 8, let me look at this one. Oh, okay. All right. So let's do this one together. Okay. So let me pop this up for everyone to try. All right. So we're going to work on number 8 right here. Okay. All right. So let me center this. The ratio of red marbles to blue marbles is 3/4, and there are 42 marbles in the bag. How many are red? Right. Okay. So I'm glad you asked this question. Pretty typical. What can show up on the TEAS? So what we have is a ratio of 3 to 4 red to blue marbles. So for every 3 red marbles, we have 4 blue marbles, and we have 42 marbles total. Did I read that correctly? Right. And then what we're supposed to do is we're supposed to find red marbles.
Professor, please show your screen.
Oh, okay. All right. So all right. So we have this right here. Okay. So the question says we have, for every 4 blue marbles, we have red marbles, three red marbles, and we have 42 marbles total. How many red marbles are there? Now, the easiest way to do this is to convert this ratio. So instead of doing red to blue, it's easier to go for every 7 marbles total, I have 3 red. And then how'd you go get that total? Well, 3 plus 4. So for every 7 total marbles, 3 of them are red. So what I did is I matched this unit with that unit. Okay. So now I have 42 marbles we'll say 42 total. Well, actually, I'll do it this way. I have 3/7 red over total, right? So for every 7 marbles, I have 3 red. And this is equal to 42 total over X red. So now I get X is equal to, and I'll bring this 42 up, 3 times 42 divided by 7 is equal to 18 red marbles. Did that help at all?
Yes, thank you.
Okay, thanks, Raul. Anyone else have questions from homework? Okay, I think, we ran out of time. Okay, let me stop this. Give me 1 second.